All right. Greetings, wonderful people. So let's see. Now, yesterday we covered this part here, that determined the solutions of piecewise functions and graphing piecewise functions. For today, we're going to do this second objective, so that is to find the value of the given inputs for greatest value functions and graphing greatest value functions. So let's move on over there, and this is where we last left off. So I want you to think about this one, and this is probably something that you've seen before. Imagine that if you had $3.50, how many hot and spicy chickens could you buy? And think about that, because this is a problem you see all the time, but it's always not really given in a realistic manner. So these are dollar sandwiches, and generally, the answer I'm going to get is about 3.5. And what's happening with that is students will usually say something like this. So it's $1 per sandwich, and it would be $3.50. So if I divide both of them by 3, that means the number of sandwiches I could get would be about 3.5. But again, that's not really likely. So what about this half? Is it possible to go into a McDonald's and buy half a sandwich? No, it's not. You know, as far as I know, I've never seen anybody buy a half a sandwich. They only sell you whole sandwiches. So in this case, the real answer would be 3. The real answer would be 3 because, again, you cannot buy half a sandwich. And this is a lot more realistic because it's very rare, and this has happened to me once, but you can go into a store and spend every last dollar and penny you have in your pocket. But more often than not, you are going to walk away from the store with some money left in your pocket. So in a way, this is a little bit more realistic if you're talking about shopping or anything like that. So let's go ahead and find out what the greatest integer function is. So what is a greatest integer function? So we write it as, so there's f of x. So it just means it's a function. So function of x is equal to, and we have these double bars. So they're double bars and x here. Okay, so that's the only thing that's new. And we have the symbol here that shows that this is the greatest integer. And it's got to be less than or equal to x. So again, just think about it in terms of that sandwich, right? How many can you buy with this many? So if you had, say, $3.99, could you buy a fourth one? Well, probably not. Well, let's see. Well, I know they say they're 99 cents, or they say they're, no. They say they're $1. They say they're $1. They don't say 99 cents. So yeah, if you had $3.99, you would not be able to buy an additional sandwich. And basically, you can think of it like this. It means that you're going to round down. So round it down to the nearest integer. So that's going to be, again, a whole unit. And it can also be negative too. It's also called the floor function sometimes. So floor is a kind of an easy thing. So like if I had a building, right, like a 5-story building, and I were to pick something up and hold it and drop it, it's going to fall to the floor. So if I'm on the 3rd floor, it's going to be about 30 feet off the ground or so. So that's hopefully a good way to think about it. Let's go ahead and look at evaluating them. So f of x equals the greatest integer of x. So find each value. All right, so let's go ahead and start with this one here. So f of 7 equals, and in this case, it's just going to be 7 because it says less than or equal to, which 7 is already an integer. Since 7 is already an integer, if we round it down, it just stays where it is. So again, if you were trying to buy dollar sandwiches and you had $7, well, excluding tax, You could buy 7 of them. Maybe it's those people that sell burritos, you know, they never charge tax. So what if you had $2.30? How many dollar burritos could you buy if you had $2.30? Okay, that'd be easy. It'd be 2. You could buy 2 of those burritos. All right, what if you, well, okay, now this one doesn't really make a whole lot of sense, but what about negative 4.8? Now remember, we have to round down, and the more, well, the closer you go to positive numbers, the greater it is. So if you're going to go down, you go backwards. So imagine a number line. I don't have a number line with me, but you would notice that there would be, you know, the middle where there's 0, and then you'd have negative numbers, and then you'd have positive numbers. And if we have positive numbers, you always go that way, right? You always go to your left, backwards towards the negative numbers. So in this case here, we would have negative 5 would be the way we would round down in that case. All right, and that one's a very simple one. We didn't have a whole lot of anything really. But now we're going to have an operation here. So we have x minus 5 and then round it down. So that's kind of the way you would think about it. X minus 5 and then round it down. So 9. So think about it this way. So let's see if I can just, I really should put these in the right kind of bracket. Or either that, we could probably just do this in our head too. So let's imagine 9 as x. So 9 minus 5. 9 minus 5 is 4. So we're going to put 4 in there. And well, actually 4 is the answer because it's already an integer. We don't have to round it down. And then for here, we are going to have 0.5, and 0.5 minus 5, well, it would be negative 4.5, and we'd have to round it down. Let me just double check that really quick. So 0.5 minus 5, and that would be negative 4.5, and we have to round that down. So negative 4.5 rounded down, you would have negative 5. And then here, let's see what we got here. So we got 9, and negative 8.1. So negative 8.1, and they're both negative. So negative and negative will make a bigger negative. So that would be 5 plus 8, and that would be 13.1. So, but it would also be negative 13.1. So negative 13.1. And we round that down. Now, even though it's just a little bit over, it's just 0.1 or 1/10 over, that means we still have to round it down. So that would be negative 14. All right, hopefully that makes sense. But again, work on it and then round it down. All right, so for here, I went ahead and just filled in some values already. And what we're going to do is we're going to just test each of these out. So I picked some of these that have numbers between numbers. So 0, and that's going to make sense. So let's go ahead and plug 0 into our function up here. So 0, and 0 is already an integer. So that makes it true. So I can go ahead and mark that area on our graph. Okay, so in this case, 0 is 0. All right, let's try another number. Let's try 0.25. So again, thinking of a dollar sandwich, if you had a quarter, how many of them could you buy? You know, could you swindle the cashier and say, oh, well, can I buy 1/4 of a hot and spicy? No. You would still get 0. So it would still be on that line. You would still be able to buy 0. Okay, well, what about if you had 50 cents? If you had 50 cents, could you buy a sandwich? Answer is still no. And it would still be on 0. What if you had 75 cents? Could you buy a dollar sandwich there? And the answer is no. You would still not be able to buy it even with 75 cents. What if you had a dollar? And again, this is just ignoring tax. So if you had a dollar, yes, you could buy one. Okay, but what happens to all this in between here? So I have a whole bunch of stuff in between. Now, up until I get to 99 cents, we can't buy one. So I'm going to put an open circle there. In fact, let me make that a little bit better. I'm going to put an open circle here. And we're going to make a mark here just to show that it is, that whole area is covered. So if you have between 0 cents and 99 cents, you cannot buy the dollar sandwich. And what if you were to, so in this case here, if you have $1, you can buy one sandwich. But what if you had $1.50? You had $1.50, you would not be able to buy a second one. You would still only be able to buy one. So if I mark it, it would be right here. And again, we're rounding these down. So you'd still only be able to buy one. What if you had $2? So if X is 2, that would be right here. And I would be able to buy a second sandwich. Now, if I had anywhere from $1.99 right under $2, I would still only be able to buy one. All right, and now you can kind of see that there's a pattern. Sometimes they used to, well, I don't know if it's the exact same thing, but I know they used to call some of these step functions because it kind of looks like stairs. So if I had 2, I'd be able to buy 2. If I had $3, I'd be able to buy 3 sandwiches. And if I had $4, I'd be able to buy 4. And you notice that we have our filled dots here, the closed circles. And we're just going to use that to kind of complete our pattern. Let me make these open circles a little bit larger, just so you can kind of tell the difference, hopefully, between the open and closed ones. And this bar, again, it tells us that anything in between there is not going to count towards the next one just yet. And we could also continue this pattern into the negative. So line up these filled circles, the closed circles. And then line up the open circles as well. And then we fill in the areas between them. So if we were to pick a number, like let's pick one from the last slide. So in the last one, we had an example of negative 4.8. So if I go back 4 and then 0.8, 4.8 would be right there on the x-axis. And remember, when we rounded it down, we ended up getting negative 5. So if I were to go to negative 4.8 and then go straight down to look for where we can meet the line, the function, it's going to be right here. And it's going to make us fall backwards to the closed circle, the filled circle. So any number in between is going to kind of go downwards. So, and we've already seen that here with this 0.75, right? So if I go to x of 0.75, it's going to go back to the filled circle because that's the area that it has the lowest of that particular step. And again, these used to be called step functions. I don't know if they are, or maybe they aren't. They don't mention it here, or it might be something slightly different. Anyway, last thing it says is to identify the domain and range. So to identify the domain and range, well, what would the domain in this case be? So we're going to use our vertical line test again. So vertical line test. Now, I don't remember how I used to do this, but I was able to draw a vertical line and then grab the line and move it. I know I've done this plenty of times, but now it's like I just can't. I don't remember how I used to do it. Oh well. But anyway, you would imagine that line kind of moving from left to right, and we would look for any holes or gaps. So just if I were to pick an area, so again, it would move. What if I were to pick an area like -1? So remember, it would pass through this open circle and kind of run into this closed circle. And there would be no holes or gaps in this line. So since there are no holes or gaps, that means our domain is all real numbers. So everything is included in this. So everything is covered. So even if I had like say 499, where would 499 be? Be like right here. It's very, very close to that, but it would still be on this 4 area. And as soon as I went to 5, it would move up to this circle here. So again, there are no holes or gaps in this, in this one, in the domain. And for the range, let's see, range. So same thing, we're gonna use a horizontal line. So starting, with a line that goes straight side to side, we're gonna raise it slowly. And you notice that in this case, there are some gaps. So if I were to, pick, say, what is this, -1.5 or -1.4, it would be a little bit low, but there's nothing there. I'm able to make a horizontal line that does not touch any part of the function. Now, if I were to move it a little bit upwards, it is intersecting with this entire line right here. So in this case, what we would do is, well, we gotta think of a set of numbers. Think of a set of numbers that this would have all of the pieces in there. And in this case here, that would be all integers. So any integer is going to work out. So if I pick, say, -4, yeah, that's going to work out. We are able to get a number or something for -4. But if I say -3.5 or any decimal between any of the numbers, any of the integers, then it's not going to work. So only the integers are going to count. And I think most of these are going to kind of be like that. But just like the last lesson, I'm not going to be really strict on the range. I know range can be difficult, but again, please try your best on this. It's not, don't be so afraid that you don't want to try it, but at least try something. Because some of these ranges, just like the last lesson, can be very difficult at times. All right, so let's go ahead and move on to number 4. So let's see what we got here. So same thing. We have our x marked in the greatest integer function. Same directions, right? So we use the table, make a pattern, and graph it, and then identify the domain and range. So here I have 0. So let's go ahead and plug 0 in here. Now, this one's a little bit different than the second example when we were introducing the double bars thing. And then this one here says we should round it down first and then -5. All right, so 0, and since 0 is an integer, we're just going to leave it as 0. And now the bars are gone. We used them up. Just like an absolute value or a set of parentheses, if you use them, they're gone. So in this case here, x is now just going to be 0 and by itself, so it becomes 0 minus 5. So 0 minus 5 is -5. All right, let's plug in 0.5. So take 0.5 and put it in here. And now if we round it down, 0.5 is not an integer, so we're going to have to round it down to 0. And this would be -5 again. Okay, and then let's use 1. 1 minus 5. So again, 1 is already an integer, so if I round it down, it's going to stay exactly where it was. And 1 minus 5 is going to be -4, so put -4 in here. and 1.5. So put 1.5 in here and round it down, that would be 1. And you would just have 1 minus 5 again, so that would still be -4. All right, and we pick an area between some of these integers, like in this case, again, 0.5 and 1.5. Those are probably your best bet. So if you have to make your own, pick at least a few of them that are going to be in between integers, in between whole numbers, because that's going to tell you where the steps are. So in some cases, you might know where the steps begin, but you don't know where, where the flat area is. So in this case here, let's keep going. So I have 2. So for 2, well, 2 is already an integer. So 2 is going to be, well, rounded down to just 2. 2 minus 5 is -3. And then 3 minus 5, so 3 minus 5, that would be -2. And 4 minus 5 would be -1. Now let's, so just to show you again, I'm going to graph it. So 4, -1, let's put that here. So over 4, down 1. And we know that this works, okay? We know that this is going to be a filled circle because it is equal to that number. And we didn't do anything, so we didn't have to round down, so we know for sure that it's got to be that number. And here again, we have over 3, down 2. So over 3 on the x, down 2 on the y. And then here I have over 2, down 3. And then I'm going to kind of show you I'm going to just show you the integers. So let's go skip. I'm going to skip this one for now, and we're going to go to 1, -4. So over 1, down 4. And then here we have over, well, 0, down 5. So over 0, down 5. Now, the reason why we have to pick these numbers like 0.5 and 1.5, again, it does show us where the steps are. Because there is a similar function, and I don't know if we're actually going to get on this one, but it would be kind of like rounding upwards all the time. And it would, okay, don't write these ones down because this is wrong. But sometimes you can have functions that look like this. But if we plug in 1.5, -4, so over 1.5, which would be here, and then we'd go down 4, that would actually be right here. So this would be the legit point on the graph. So that means these circles don't go there, they go on this side of each dot. And again, there is a function that does work, and it does go the other way. So just to avoid messing this up, you can always just check it, okay? So just like checking an inequality, plug in a number and see if it works out. See if it'll make a true statement or whatever. If it makes a false statement, you can try something else, or if there's only 2 options, then it's got to be the other option. But it's going to look like that. And that's what these numbers are for. That's why we have the 0.5 number. So pick at least 1, although 2 would probably be better. And it looks like we are done graphing this one. So let's go ahead and identify the domain and range. So domain, and again, this one has no holes or gaps in it, because if we move a vertical line, yeah, there are some areas where we have holes, but they are covered by an area that we have a solid circle, and that solid circle means if you pick there, it's going to go to that one and forget the circle one. So in this case, we have all real numbers. And then range, I think, is going to be the same. It's going to be all integers. And I think most of them are going to be like that. I think there are going to be some odd ones that are going to be a little bit different, but hopefully they're not going to be too different. All right, and we don't have that many to go. And like I said yesterday, I decided to go ahead and split this one into 2 lessons because I know sometimes students will confuse this with the piecewise functions. So I thought it would be better to split it, because the last time I did this, I had students doing both of them as piecewise or both of them as the greatest integer functions. All right, so let's go ahead and move on to the next one. Now this one here, let's see. We've got a 2 on the outside, and then we have x minus 1. So the minus 1 is inside of that grouping symbol. So in this case here, it is considered a grouping symbol. So you treat it just like a parenthesis. If you see that greatest integer function thing on there, you would have to do that first before multiplying it by, say, 2. So again, let's go ahead and do that. I just picked the same numbers. I don't know if this is going to work out or how it's going to work out, but if it doesn't look like you're going to get on the graph, then you might have to try some different numbers. So let's go ahead and put 0 in for x. Now we have to minus 1 and then round it down. So 0 minus 1. So 0 minus 1 would be negative 1. Negative 1, and well, that would be an integer, so now I'm going to round it down. Since it's already an integer, I cannot round it down, so it's just going to stay negative 1. And in this case here, it's going to be 2 times negative 1. Oh, and again, this is just like a parenthesis. You would multiply the 2 on the outside the same way you would do it if it was a parenthesis. And then here I have 0.5. And again, these are here to help us. So we should get one of the numbers that we already have. So I'm guessing it's going to be negative 2. Again, so 0.5 minus 1. So that would be negative 0.5. Negative 0.5. And then we round it down. So now we have to round it down, and that would be, well, negative 1. So again, negative 0.5, and if I round that down, it's going to be negative 1, because you always have to move backwards on the number line. You got to move backwards towards the negatives, and that's how you round it down. So if you have a number that's already negative, it's going to go further into the negatives. So anyway, negative 1 times 2, and that would still be negative 2. Okay, and then we can go to 1, so plug in 1. So 1 minus 1 is 0. 0 times 2 is 0. And then plug in 1.5. So 1.5, so that's like $1.50 minus $1 means you're going to have 50 cents or 0.5. And what that's going to do is it's going to, well, we're going to have to round it down first. So 0.5, if I round that down, it's going to be 0. So now I have 0 in here. And again, treat it just like a parenthesis. 2 times 0 is going to be 0. And then let's move on to the next one. 2 minus 1. So 2 minus 1 is going to be, well, 1. And then it's already an integer. So since it's already an integer, 2 minus 1 is going to be 1, and then 1 times 2. So 1 times 2 is going to be 2. And then let's try 3. And we're, again, we only need a few of these half numbers or in between numbers. Decimal numbers, I guess, is probably the best way to explain it. 3 minus 1. So 3 minus 1 is going to be, well, 2. 2 times 2 is 4. And now we have 4, plug in 4 as x. 4 minus 1 would be 3. 3 times 2 is 6. And again, this should help us get the pattern. And let's go ahead and start here. So 0 minus 2. So 0, negative 2. So go down, negative 2 here. And then here I have 0.5. So if I go over 0.5, that would be here. I would have to go down 2 from here. So that means this is part of that line. All right, and let's keep going. So over 1, and I stay on the line. I don't go up or down. And then 1.50. So that area is also included on the graph. So again, it belongs to, with this one here. And then over 2, up 2. So over 2, up 2. Follow that one. And then over 3, up 4. Over 3, up 4. And in this case, it looks like I'm not going to be able to include this one and still be on the graph. So over 4 up 6 would be about here. But again, now you can see the pattern. And if I keep going back this way, I should be able to get that pattern again. Now again, I know that there's a bar here, and this bar goes all the way to the open circle. That tells me that I should go up to the next dot. So now I'm just going to go ahead and fill these in and cap it off at the other end with an open circle. And there we go. So that's it for this one here. And you notice that we have a bit of a bigger gap in here. And with some of these, I can kind of tell that when it comes to the range, there's going to be a bit of a weird thing. Now, even though these steps are a little bit higher, right? Everything is still covered. All the steps still have enough covering to where it's not going to cause any holes or gaps in the line. So everything's covered. So that's going to be all real numbers. But again, the range on this one I can kind of tell is already going to be a bit of a weird one. And in this case, if you come across something like this in your homework, okay, just try your best to answer it. And think about it. What numbers would be counted? You could probably just say evens. But I think it'd be a little bit more descriptive to say even integers. Because, well, 0 is an even number, 2 is an even number, and 4 is an even number. And if I were to pick something like y of 3, so remember the range is the r values. If I wanted to find a way to get 3 out of this function, I can't do that. We cannot get 3 out of this. We cannot get 1 out of this. We cannot get -1 or any odd number. We can only get even numbers out of this function, which if you look at the table, yeah, no matter what you put in there, it's going to be either rounded down or multiplied in a way that it's going to have to always be even. Now, if you're on the homework and you see something like this and you were to write something like, well, I don't know, numbers divisible by 2 or multiples of 2, I'd probably still accept it. Well, in this case, you know exactly what it would be. But like if it was like if it was going by 3s or going by halves, something like that, you just have to use your best judgment and say, the numbers are increasing by half or 1/3 or whatever, whatever you can come up with. Oh, and would you look at that? Where it looks like we're on our last exercise. All right, so this one here we have 1/4. Oh, no. 1/2 x plus 4. All right, how is this going to affect our graph? So let's go ahead and start filling in what we have. So let's go ahead and put 0 in here. So 0 times 1/2. Well, that's easy. 0 times anything is always going to be 0. So I'm going to go ahead and put that in there. And we are going to have 1/2 times 0 is 0, 0 plus 4. And then here we have 0.5. 0.5 times 1/2. So 1/2 times 0.5. And I'm going to have, well, I'm going to change this one into a fraction as well. Actually, I could have turned them both into decimals. Oops, sorry, I'm getting ahead of myself. But I'm going to go with fractions just so that way we can kind of see what's going on. So, fractions are something you should practice with. Multiply the top number, so 1 times 1, and then bottom number is 2 times 2, so that'd be 1/4. So 1/4 plus 4, so that'd be like 4.25 or 4.25. And if we round it down, it would still be 4. What about 1? Let's plug 1 in there. So half of 1 is, well, half or 0.5. And add 4, that would be 4.5 or 4.5. 4.5 is going to get rounded down to just 4, so that makes this one also a 4. 1.5. So 1.5 times half. And in this case here, this would be, well, 1.5, how would be an easy way to calculate this? I guess if you wanted to use decimals, and since we did this one with fractions, let's go ahead and do this one with decimals. So 1.5 times 0.5. And with this one, you could do you could use a calculator, or you could just go 5 times 15 and then move your decimal over. And that would be 0.75, which 5 times 15 would have been 75, and then move your decimal 2 spaces back in. And that would be 0.75 here. 0.75 plus 4 would be 475. And if we round it down, thinking again, how many dollar sandwiches could you buy with $4.75? Well, they're not gonna sell you 3/4 of a sandwich. They're gonna tell you to just, save up and buy a 4th one. And you notice that we have a lot of these that are 4. So let's go ahead and keep going. Let's go with 2. So in this case, I'm going to put 2 in here. So 2 is times half. So half of 2 would be 1, and 1 plus 4 would be 5. And now we round 5 down. And since it's already an integer, well, we're going to get 5. Let's try 3. So half of 3, and if you want to write these down, go ahead. So half times 3 plus 4, and you could type this out on a calculator, but it would be 3/2 or 1.5, or 3/2 would be 1.5. And if you were to add this, it'd be 5.5 or 5.5. And in this case, again, if you had $5.50, you would still only be able to buy 5 of the dollar sandwiches. All right, let's try 4. So with 4, plug 4 in there. Half of 4 is 2. 2 plus 4 is 6. So round it down, and it's already an integer, so that should give us what we need to complete the table. Now let's go ahead and mark some of these down. So 0, 4. So 0 up 4. And this is definitely a point on the graph. 0.5 is 4. Over 1 up 4. Over 1 up 4. And then over 1.5 up 4. So 1.5, so go 1, and then another half. And it would be up 4 again. Now, if I were to go to 2, over 2 up 5, I would get a number, which would mean that I would have to pass through an open circle here, because all these points have to be included with this step. And hopefully we can, okay, so over 4 up 6, over 4 up 6. So that would be the next one, which we don't have here, but hopefully we have enough information to see what the pattern is going to be. And we're going to have to do a little bit of assuming here. So it looks like it goes up 1 over 2. So just like the slope of a line, up 1 over 2. And in fact, actually, this kind of does look like a line. So if we were to just imagine a line, y equals 1/2 x plus 4, start with 4, and you'd have a line that kind of goes like this. All right, and that's kind of a shortcut, but don't count on it too much. But just keep these dots lined up. So I have each of these closed circles, and I'm going to make a line of open circles. So again, in this case, down 1, back 2, down 1, back 2, down 1, back 2. And then join them with a bar that shows everything in between here goes to that number. And this one kind of goes off of the graph here, so we can't see the rest of it. And there we go. So that it would be it for the graphing. And you can see that these are kind of long steps. They're not steep steps, but they are kind of long. And the domain in this case, and again, there are no holes or gaps, even though there's long steps, there's nothing missing. So like for instance, if I had two holes above each other, that would be a hole. Or a gap, just a reminder, a gap would also be something like, a gap would look something like this, where there's obviously a jump from here to there. And a hole would be something like an open circle above another open circle. So that means it would pass through both of those. But we don't have any of those. And again, this is a sometimes called a step function because it almost always is a function. And remember, in order to be a function, you cannot get a double value for x. So two x values cannot be the same thing. So in this case here, it's going to be all real numbers again. And the range in this case is going to just be integers again. So we don't need to worry about saying like odd or even integers or anything like that. But again, on this, just try your best. Just try to get as close as you can to whatever, number, whatever number set that it can give you. And again, I'm not going to be really strict on it. I'm going to kind of be a little bit more lenient on this one, just because I know not everybody is familiar with every set of numbers, which, well, you can, but I guess it'll just be a lot easier. Anyway, I guess that's it for today. Kind of a shorter lesson, but like I said, we're just continuing another lesson that we've already had from yesterday. And we'll start the next one on Thursday, so we'll see you back there again. Anyway, that's it for today. So I will see you again later. Bye-bye.